Okay, everyone, I've got the top of the hour on my clock, so we're going to get started. So welcome. Hope you're all having a good day so far. Thank you all for joining me, and thank you to CSI GeoTurf for setting up this webinar so that we're able to get together today. My name is Sam Justice, and I'm one of the engineers here at Presto Geosystems. We manufacture erosion control, stormwater management, and porous pavement products. We're located in northern Wisconsin, kind of near Green Bay. We work closely with CSI GeoTurf throughout Michigan on a wide variety of projects. Most of you know the great team at CSI GeoTurf, who is our distributor for the entire state of Michigan. So we're going to dive right into the presentation so that there's enough time for questions at the end. The focus of this presentation is going to be on rigid porous pavement with both gravel and topsoil surfaces for effective stormwater control. So the natural first question is, why are porous pavements needed, and how are they different than the standard pavement surfaces we usually see? Porous pavements are a class of solutions that address in a cost-effective way regulations that need to be met. After 40+ years, the Clean Water Act continues to create the need for stormwater management for both quantity and quality. And most states have developed non-point pollution regulations with specific targets. Local regulations may require even more stringent standards if the project is near a protected wetland or water source. Porous pavements are one way to meet these criteria while still performing in a structurally meaningful and long-lasting way. Another reason to choose a porous pavement system is because you want one for your site. If you have poor soil conditions, which are becoming more common because better suited sites are becoming more scarce and land is at a premium. Maybe you have high stormwater management value, which is the desire to make the best use of valuable high cost land and reduce the need for stormwater ponds by increasing the porosity of your pavement. Porous pavement systems handle stormwater at the point of impact, percolating the water where it falls, and avoiding unnecessary conveyance pipes or structures that otherwise might be needed. Sustainable solutions are also popular with the public now because of the high percentage of recycled materials, reduced landfilling of the abundant recycled materials, and the ability to achieve green energy credits on your site. So there are a couple different porous pavement options available. The more traditional and possibly the more well-known option for porous pavements is to use the porous version of traditional pavements, concrete, asphalt, or paver blocks. These applications allow for normal traffic frequency use, have increased infiltration over non-porous versions, which can help with stormwater requirements. Hard surface porous pavements act very similarly to their non-porous counterparts, but they often suffer from durability challenges. The biggest difference with the porous version of these hard pavements is going to be the cross-section. All three of these methods have deeper cross-sections, as much as 3 feet or more, depending on the requirements of the site. And they all have a choker or a bedding course between the pavement and the open graded base layer. The choker course is required to support the pavement layer, but it also restricts the infiltration rate of stormwater because it's made of that tightly packed stone. However, there are some significant drawbacks to using these traditional methods. Cost is one of the biggest factors, both during installation because of the need for specialized materials to create the pavement and specially trained contractors to know how to properly install this type of system, and because of the higher lifetime maintenance expenses for the project. Regular deep cleaning is required to reduce clogged areas, as is resurfacing or replacement of the lost materials due to raveling, which occurs because of the weak bonds within the porous concrete and porous asphalt. In general, porous concrete and asphalt surfaces tend to look unfinished, leading to some questionable aesthetics. So if that's important on your site, it's something to consider. So here at Presto Geosystems, we offer 2 different types of porous pavement systems. Instead of adaptations of existing pavements, our solutions are designed from the ground up to function as porous pavement and to manage your stormwater runoff. The first is a vegetated porous pavement system. It's used for occasional or infrequent traffic and delivers the aesthetics of a green space. Local vegetation can be used to create a seamless look with existing plants. And a unique blend of topsoil and clean aggregate is used as a base layer, allowing for root growth while providing the necessary stabilizing strength. Our other option is an aggregate surface porous pavement. This system can handle higher frequency traffic, including daily use. The low-cost confined aggregate can perform as an on-site stormwater detention basin, reducing or eliminating the need for conveyance pipes or other stormwater infrastructure. The structural strength and loading capabilities depend on your site subgrade, infill, and your base materials. So these are the important characteristics that are inherent to the GeoBlock vegetated porous pavement system. The GeoBlock system is a rigid porous paver unit, meaning that the panels are not meant to twist or bend. This is quite different from other porous pavement units that are available, which are considered flexible systems and have significantly reduced loading capabilities. The attributes that have the biggest impact on the load distribution are the paver wall strength and the stiffness, and the strong tabular connection between the panels. An important aspect of the GeoBlock units is the large amount of open space in the bottom of the cells, which allows for full root penetration into the base layer, so the grass surface is thick and uniform. An engineered base of topsoil and aggregate mix provides that optimum growing medium while supporting your vehicle loads. The other one, the GeoPave, which is the aggregate surface porous pavement unit, are very similar to the GeoBlock units with the same rigid paver characteristics, but with specific features needed for the performance of an aggregate infill. The main difference that I want to highlight is going to be the monolithic mesh bottom. This is a molded in-place mesh on the underside of the paver unit. This mesh keeps the stone infill from migrating underneath the units, and the integrated nature assists in the overall rigidity of the paver unit. The lattice bottom spreads the load similar to a snowshoe, so the wheels don't create ruts. The GeoPave units are locked together with a connection device to create a fully integrated, contiguous pavement that's highly resistant to traffic stresses. GeoPave units are designed using a finite element analysis and are not going to lift up over time, which you might see with other systems. So now that we've talked about the characteristics that make rigid porous pavement units special, we can go on to what the benefits of choosing these type of porous pavements over a hard surface pavement. Because the GeoPave units have a high percentage of open area and utilize a highly permeable open graded aggregate infill, the stormwater infiltrates exceptionally fast. And in the GeoBlock units, the loose and protected topsoil allows water to infiltrate faster than a typical vegetated area on site. Both GeoBlock and GeoPave systems offer significant storage of stormwater in the cross-section as it moves into the groundwater system. Because the water infiltrates through the system, there is minimal sheet runoff at the surface, reducing flooding potential on and around the pavement. Other paver systems will have a glued-on geotextile fabric underneath the paving unit, which really prevents that water percolation. It's going to go much more slowly. And pavements that allow water to flow through the surface into a base of open graded base aggregate can reduce the requirements for stormwater storage at the surface. The rate of infiltration of both the porous pavement material and your subgrade soils, along with the porosity of the base material, is going to determine how much surface storage may be required. If your native subgrade has poor infiltration, or if you're required to direct the water to a central location, collection pipes can be installed in the open graded or engineered filled base courses. The pipes can have perforations to collect the water and be sloped to maintain velocity without affecting your surface grade. Providing a wrapped perforated pipe is typically not recommended unless the base is clean. it may be better to provide a geotextile filter around the perimeter of a drainage trench with the pipe encapsulated in that clean stone. The main thought is to prevent clogging, and the method used is going to depend on the stone type. So you can have a nice flat parking lot and still drain your stormwater with ease. Structures like this in the base course do not negatively affect the overall strength and stability of your paver system. So you can know you can install them and not worry about losing strength. So the idea of paver strength gets back to the differences between a rigid wall system like our GeoBlock and GeoPave and the flexible systems that are available on the market. Our paver units have a high crush strength because of their rigid and shared walled connections. Pavers have enough strength to allow for less base requirements to support the load, reducing potential cross sections by up to 67%. The surface of the porous pavement resists concentrated rutting as the load is dispersed across the rigid pavement. So no wheel ruts or sunken drive lanes are going to form and cause failure points. The units are strong enough to drive on when they're unfilled, which makes installation fast and easy. The units offer a large paver size, 20 inches by 40 inches, or about 5.5 square feet. The interconnected system joins each unit with strong connectors, common cell walls, and on the GeoPave aggregate system, that mesh bottom that forms a continuous pavement with high distribution of vehicle loads. This allows for higher vehicle weights to drive on the system with a thinner cross section and allows for the system to be installed over poor subgrades. Systems with disjointed cell walls tend to flex, so they don't have that same load spreading capability. The shared wall system and strong connections create a framework that's highly resistant to movement or breakage from vehicle turning stresses and torsional loads. So the GeoPave and GeoBlock systems are not just straight drive lanes, they are full service vehicle areas, allowing for starting, stopping, turning, and everything in between. The panels are not going to be damaged from any normal vehicle activities, even from the heaviest of trucks or semis. And the paver units align well with existing asphalt or other pavement. Here we see a car dealership parking lot edition. The paver units come in rectangles, but they can be field cut to handle curves, existing structures such as manholes, and other obstacles that are common on site. The GeoPave and GeoBlock units work in concert with hard surface pavements, and so they're porous so they can handle the sheet runoff from those adjacent impervious parking areas. This is a great way to add additional parking spaces while still meeting stormwater requirements at a site, with no need to create stormwater infrastructure such as drainage swales or ponds. The cells of the GeoPave units are meant to be visible and were designed with the herringbone pattern, similar to a paver stone aesthetic. And additionally, the infill stone color can be varied to create a sense of separation, useful for walkways, parking lots, and road shoulders. The GeoBlock units allow for full vegetation growth with a natural look so that the cell walls are not visible through the grass. So whatever look you're going for on your site, you can achieve with these products without that unfinished look that's so common for porous concrete and asphalt. Reducing a site's overall environmental impacts can help you meet green infrastructure, low impact development, or green building goals for building in protected or densely populated areas. It can also help you meet stormwater requirements that limit the amount of hard surface in your landscape plans, which is becoming increasingly common in cities and townships. This is something we experience all across the US and are absolutely willing to help you achieve for your specific projects. There are a number of constructability benefits as well. The units are lightweight enough for a single person to carry 2 at a time, and the connectors are fast to install. Infill placement is fast as tracked or rubber-tired construction vehicles can drive on the GeoPave or GeoBlock units when they're unfilled, as you can see here. Paving crews and specialized paving equipment aren't necessary, and oftentimes landscape crews are all that's required. So you can save on equipment and labor costs and get these systems in the ground quickly without waiting for cure times or sequenced construction limits. The GeoBlock and GeoPave units also work on a mild slope. Because they're flat paver units, the grade does need to be gradual without sharp breaks between those grade changes. A general rule of thumb is that if the slope is flat, the panels don't need to be anchored. If the grade of the slope is more than 8% or about 5 degrees, anchorage is going to be necessary to help hold those panels in place. Or if you aren't interested in having a sloped area, you can create grass steps like this bed and breakfast did for an attractive visual appeal. And the locked-in place system requires virtually no maintenance. Place it and forget it. Owners and maintenance crews are definitely going to appreciate this. We also have bright yellow delineators available for parking lines or other markings, so you can make the space work for your needs. Other common extras, such as parking stops, are also very easy to install in the GeoPave and GeoBlock system. Presto Geosystems has created a free, easy-to-use tool to determine the right porous pavement system for your specific project and site conditions. A cross-section of the system is created based on the inputs and system requirements. And there's a way to determine exactly how deep that base course needs to be for a certain amount of stormwater storage. The tool is available on our website, prestogeo.com, and our engineering team, including myself, we're always happy to give advice or expertise when you're designing a porous pavement system. So this is just a quick look at what the Design Assistant tool provides you. It's a very basic cross-section, but it can be helpful during the beginning of the design process. If needed, there are additional calculations and CAD details that the engineering team here can provide. But it's a good first step when you're talking to regulators to show that stormwater storage can be achieved with this type of system. So let's take a closer look at the GeoPave porous pavement aggregate system. Here we have a typical cross-section for the GeoPave system. The GeoPave unit is 2 inches deep, so the overall depth of the cross-section depends on the amount of open graded base course that's required. There are a variety of factors that decide the depth of that base course, but there's a minimum of 2 inches that we require for pretty much every case. Additionally, depending on the native subsoil, a geotextile separation layer may be required. And note that there's no need for that choker or bedding course underneath the pavement unit. So there are no layers that are going to limit that stormwater infiltration. So the water is going to flow through quickly. So the biggest factor in determining the base depth is going to be the strength of the soil, expressed as the California bearing ratio, the CBR. The higher the ratio, the stronger the soil. And the strength of the GeoPave system is enough that even the highest load rating from AASHTO, which is H20, so your heavy loaded fire trucks, there's a low base depth requirement, only 6 inches compared to up to 14 inches with the lighter weight flexible systems. And it's important to note that this table is just your minimum depth requirements. The base can be increased if you want additional stormwater storage for your system. So there are a wide variety of uses for the GeoPave system, including fire and utility lanes, utility site access roads, road shoulders for runoff reduction, and trails or walkways, because the system is ADA compliant. So anything that you might need porous pavement systems for. And unlike the GeoPave units, which are rigid, there are flexible paver systems on the market that have some problems due to not having those shared common cell walls, or by allowing the stone infill to get underneath the system, causing uplift. Both of these issues are addressed with the design of the GeoPave system, with its rigid walls and that integrated mesh bottom we discussed. So just be aware that because the system says it allows stormwater infiltration, it doesn't mean it's going to be appropriate for your project site. So now I want to share a case study to show how the GeoPave system works from start to finish. The study is of a parking lot at the Citadel in South Carolina. You can see how close it is to a coastal area, which is similar to situations along the Great Lakes or other water areas throughout Michigan. The system was installed in the summer of 2009. Because this project was primarily about stormwater retention, the open graded base course was quite deep. Standard lightweight construction equipment was used with no need for any of that specialty equipment. And the crew, which had no prior experience to installing the GeoPave units, was able to achieve an installation rate of about 1,200 square feet a day, including the excavation prior to the installation of the panels. So the U-clip connectors are easy to install, and it's really apparent where they need to be placed. Some of the walls are half height, and those half height walls line up between paver units, so the contractors know exactly where the clips are needed. The clips can be installed with a single worker without needing electrical equipment. A small excavator or front-end loader is a great option for placing the stone infill. And so here's the parking lot immediately after construction is finished. Because the stormwater retention in the base, there was no need for additional surface retention, which is great for areas without space to spare. If an above-ground detention pond had been installed, there wouldn't have been room for the additional parking spaces. So this was a great compromise between function and environmental concerns. And then here we are about 2 years after installation. The lot is still in use and looks as good as it was the day it was placed. No maintenance was required for the 28 months during this installation. Some recommended tips for keeping the geopaved pavement in good shape include keeping the lot clear of organics, such as fallen leaves, by raking or leaf blowing, and making sure snowplow blades are kept about an inch above the geopave unit. I know that placing porous pavements in cold weather or snowy conditions is a concern for many regulators. So we have quite a bit of information available on our website, answering a lot of the common questions we see. Or feel free to contact us directly, and we'd be more than happy to alleviate some of those concerns. So now we're going to switch and focus on the GeoBlock, the vegetated system. So here's a typical cross-section for the GeoBlock system. The GeoBlock panels come in 2 depths, either 1.2 or 2 inches. The depth of the overall system is also going to depend on the amount of base course that's required. Topsoil or sod is placed into the cells, and the roots reach down into the base. The base course is a unique mix of that topsoil and open graded aggregate, which allows for enough soil to promote root growth with the aggregate supporting your vehicle load. We call this engineered base. The uses for the the GeoBlock grass pavers are very similar to the GeoPave aggregate system, but the grass pavements are meant to be for occasional use only. So fire and utility lanes, access roads, special event or overflow parking for parks, churches, stadiums, that sort of thing. Basically, anywhere that you don't anticipate vehicle traffic every single day. And the 2 depths allow for some flexibility of choice. If the expected loads are very light, think cars and pickup trucks, you don't need to support as much as the roads that are going to carry fully loaded fire trucks. So the 2 products are similar except for depth and perform in the exact same way. And we can help decide which product is going to be the right choice for you. The engineered base acts the same as it does for that GeoPave system, with higher loads requiring a deeper base. The deeper 2-inch GeoBlock 5150 units can have a shallower base depth overall. So if having a thin cross-section is important, that's the way you're going to want to go. Thin cross-sections may be required if there are shallow utilities that needed to be avoided, or if excavating costs are too great. And again, these tables shows the minimum depth requirements. More depth can be added when stormwater storage is required. And there are flexible systems for vegetated surfaces as well, and they suffer from several problems. The flexible systems tend to rut in areas of soft soil, and because they can warp due to vehicle loads, those ruts are just going to get deeper over time. And these systems require the infill to be sand, not topsoil. And it's not hard to imagine the difference in grass growing in a sand versus a nutrient-rich topsoil. And so we have a case study for the GeoBlock system as well. This time it's actually in Michigan. So the Nottapawasee Huron Band of the Potawatomi was constructing a new powwow area and was looking to create an area for parking trailers nearby. The ground was a very soft clay that often caused heavy trailers to get caught and bogged down. Because this is a wilderness area, the NHBP was looking for a natural look rather than an asphalt parking lot. The system was installed in October of 2019, so everything was down before the snows came in. The ground was leveled off and the GeoBlock 5150 panels were placed. They were laid in a herringbone pattern, which is recommended when there's going to be bi-directional traffic or the lots of turning movement, which is common in trailer parking areas. The engineered base was 2 inches, which satisfied the loading requirements based on the expected vehicles. And then the cells were filled in with the local topsoil. And so this is the final look at the end of installation. All of the panels are filled with nutrient-rich topsoil, which allows for that full grass growth come this spring. The panels are visible now, but they will be completely covered once the grass has started growing. But in the meantime, during the winter months, this system can be driven on and used as needed. So once the full grass growth is here, the lawn can be maintained with a standard lawnmower and landscaping maintenance. No special maintenance systems required. So little plug for the engineering team here at Presto Geosystems, including myself. We work closely with landscape designers and engineers, offering a free project evaluation service for each porous pavement product that you may have. We'll analyze your site-specific data and offer a recommendation that is going to meet your project needs. So we've made it to the end of the presentation. So today we covered the GeoPave and GeoBlock rigid porous pavement systems and have detailed many advantages they may have over traditional hard surface pavements. Benefits such as stormwater management, high vehicle loading capacities, and aesthetic aggregate or vegetated infill are some of the great aspects to using the porous pavement system. So my contact info is here, or if there are any questions that come up later, and info for CSI GeoTurf for questions about pricing and local support. A follow-up email is going to come to you in the next few days, so keep an eye out for that. That email is going to give you instructions on how to receive your PDH credits for attending today's webinar, and it's also going to give you the link for this recorded webinar. It's available either on our webpage or we have a YouTube page, so if you missed it, if one of your colleagues wants to see it, or you just want to review this information later, you'll be able to watch this whole webinar again. So I'm going to unmute everybody's mics, and if you have any questions, feel free to shout them out. I will try and mediate as much as I can. But I also know that it is, middle of the day, everybody's got valuable time. So if you need to get off, go ahead. We want to say thank you for everybody attending, and I will let people shout out questions now. If for some reason your mic is not unmuting or you don't want to shout out a question, feel free to type it in the chat window. That will come and be visible to myself and everybody else. I'll be able to answer those questions as well. So either shout it out online or type it in the chat window. Okay, I'm not seeing or hearing any questions, so I just want to say thank you again to everybody, and thank you to CSI GeoTurf for starting this presentation. A question just did come in about cost. So cost is going to be dependent on which product you choose and what your site-specific conditions are. The best way for you to get a budget estimate is to contact CSI GeoTurf. Their information is on the screen. And they'd be able to get you that initial cost that you'd see. But generally, it's going to be comparable and possibly usually even a little cheaper than if you were to install, say, a porous concrete parking lot. So think about what you pay for a porous concrete. It's going to be that, probably less. Okay, I'm going to end the webinar. Thank you everyone for attending, and I hope you have a wonderful day.